chats there. Nice. Watch this. There we go. Nice. There we go. Let's see, in this one, that's muted. Good. All right. And I need to turn my Streamlabs up. Okay. I guess this will work. So we're gonna have a bit of a short stream today. That's okay. We are up to Introduction to Bitwise Operators. Let's go. All right, start here. Just a little bit. Great, this is gonna be esoteric and tricky. Yeah. Thank goodness it's Tuesday. Oh, might as well live it. Oh, there we go. At least I didn't do what I did yesterday, but we're not talking about that. Okay. What are, oh, time for notes. Notes. We gotta write it down. We are looking at bitwise operations. Operations that directly manipulate bits. Oh, so it does exactly what it sounds like. So what do you mean esoteric and tricky? I think the definition is not quite all-encompassing there. Operations. Okay. In all computers, numbers are represented with bits. And yeah, series of zeros and ones. Okay, yeah, everything is bits. Yep. Okay. Okay. You're not really going to see bitwise operators in everyday programming. However, they do pop up from time to time, and when they do, you should have a general idea of what's going on. Okay. I'm just going to write these down. 6 bitwise, basic bitwise operations. Print 5 greater than 4. Right shift. Print 5 less than 1. Left shift. Print 8 and 5. So bitwise and print 9 bar 4. Where would we even, where is that bar at? On my computer. Where do I find this? C///. I have a reduced size keyboard, maybe that's why. I don't know. Let's see. Bitwise 4. Print 12. Carrot stick 42. Bitwise XOR. Front tilde 88 is bitwise not. Okay, press 1. Okay. And it prints out 0, 10, 0, 13. 8 plus 5 is 13, right? Wait, 8 and 5 is 0, right? This one's 0. Left shift is 10. 8 and 5, the AND is 0. 9 or 4, it's 13. 12 XOR 42 is 38, and tilde 88 is minus 89. It makes no sense, but I'm just going to write it down. Maybe we'll, they say we're going to figure it out, let's see if we really can, eventually. 13. 38 minus 89. Oh, base 2. No. That's funny. There we go. Okay. Each place can hold one of two values, 0 or 1. Counting pattern is the same as in base 10, except when you carry over to a new column, you have to carry over every time a place goes higher than 1, as opposed to higher than 9. Okay, the numbers 1 and 0 are the same in base 10 and base 2, but base 2, once you get to number 2, you have to carry over the 1, resulting in representation 1, 0. Adding 1 again is 3, and adding 1 again results in 4. Okay. And it starts at 0. Okay, contrary to counting in base 10, where each decimal place represents a power of 10, each place in binary represents a power of 2, or a bit. The rightmost bit is the 1's bit, 2 to the 0 power. The next bit is 2's bit, 2 to the first, and then 4, 8, 16, 32, and so on. Binary number 1010 is 10 in base 2 because the 8's bit and the 2's bit are on. Ah, okay. 8's bits for, oh, and it counts like that way too. Okay, so I shouldn't read it as 1010, it's actually 0101. 1's bit, 2's bits, 4 bits, 8 bits. Okay. In Python, you can write numbers in any binary format by starting the number with 0b. When doing so, the numbers can be operated like any other number. Zero B. Zero B 1 1. What are we saying that equals? We know 1 would be 2, right? No, it would be 1, right? And this would be I'm not good at this. 3. Okay, so this is 3. And this is 1, so this will equal 4. I'm not good at this yet. Yet. We'll get there. Okay. Because 0 is 0, so 1 is 1, and then you add. See, I'm thinking you add the 0 behind it, but you don't. You add the 1 in front, and the 1 at the back becomes a 0 to count up 1. Which is why here, these 2 become 0s, and you add a 1 to the front. Okay. I'm just going to write these ones down too, just as a reminder for counting, because I'm not really familiar with these two. So. Let's see, 1, 0, 1 is 5. And 1, 1, 0 is 6, right? And 1, 1, 1 is 7. Okay, that should work. I'm going to turn this down just a little bit. How is my sound? I can't tell. Let me turn this down just a little bit. I wonder if that's better, or if it's too quiet. I don't know. How's that, maybe? We'll see. We shall see. Okay, and so it's going to print some stars, then it's going to print 4, and then it's going to print 6, no, 3 times 3, 9, right? But is it, we'll see, let's run. 4 and 9, yes. Oh, and it printed each of the numbers. Okay. Next, hopefully we can get through this module today. Fill out the rest of the numbers with their corresponding binary values. Up to 12 in the editor to the right using the 0B. Equals 0B 100 equals, oops, I put, oh, it's 0. 0B. 0B 101. 0B 110. Right, that's 6, right? Yeah. And oops. And then equals, oops, of course, 0B 111 equals 8 is 0B 10 I think. Right, because we added 1 there, and then that 1 becomes 0, and then, or is it like, I don't think it's 1000. One, 0, 1, 1. 1 1 0 1. No, 1 1 0 0. What's this one? 1 1 0 1. And 12 would be 1 1 1 0. Maybe. Give it a try. Nope. Okay. So all of these are ones, so 8 has to have an extra digit. And when you move up 1, let's see, starts at 0, then it goes 1. Then you add 1 here, and then it goes 0. So maybe 8 is 1 0 0 0. And that makes this 1 0 0 1, and that makes this one 1 0 1 0, and that makes this one 1 1 0 0. No, 1 0 1 1. And this one is 1 1 0 0. Yes, okay. Not too bad. Not too bad. Bin function, okay. Hopefully the lesson's easier from here on out. They said that was the hardest part. I don't know. I don't know about that. We will find out. Okay, so bin. Makes this nice. Print a number in its binary representation. Binary form. Yeah. Bin takes an integer as input and returns the binary representation of that integer in a string. Keep in mind that after using the bin function, you can no longer operate on the value like a number. Okay. You can also represent numbers in base 8 and base 16 using opt and hex. Base 8. Base 16. We won't be dealing with those here, however. Okay, fine, great. They want all the way through 5. All right. Not playing around here, typing the same thing over and over again. Oh, I did one too many anyway. Next. Integer's second parameter. Python has an integer function, like we speak of already. Can turn non-integer input into an integer like this. Okay, yes. Integer function actually has an optional second parameter. When given a string containing a number and a base that number's in, the function will return the value of that number converted to base 10. second parameter is what? It is the base, right? That they return the number in, right? String containing a number. Okay. What are we doing here then? In the console are several different ways that you can use the integer function second parameter. On line 7, use integer to print the base 10 equivalent of the binary number, which would be print int 11001001 and base 10. Okay, so this is 1 in base 2, which will be 10, 10 in base 2, which was, what did we determine that was? 1010. Oh god, I didn't write all those down. I think that's right though. Zero B 100 in base 2. 111 in base 2, I think that was 3, right? No. 7. Yes. 0B100 is 6, 5. 4? 4. It's 4. It's 4. I'm guessing. No, it is 4. And then bin 5. Okay. And we said bin did what again? Returns the number in its binary form. So the binary of 5 would be 101, and then it'll return 5. Is that right? What's this one gonna return? I don't know. End of line. Oh, here. That's why. Why isn't it working? Oh, but we want to print it in base 10, so we tell it it's base 2. Say, hey, this number is base 2. There we go. Okay. Next. I didn't tweet either. I'm terrible. What are we doing here? Slide to the left, slide to the right. I have a really bad joke here. I'm going to share it with you all. It tells you how old I am. This is the electric slide. You like that one, baby?
I do.
So bad.
So bad. So bad it's tasty.
So bad it's tasty. Oh man. Left and right shifts. Okay, we saw those already. Shifting the bits of a number over by a designated number of slots. The block below shows how these operators work on the bit level. And note in the diagram the shift is always positive integer. Okay. Left means the arrows go this way, right means the arrow goes that way. So that is equal to that. I have no idea what's going to happen here, or why we're doing this, or when you would ever use this. I don't know about any of this right now. I got nothing here. They're similar to rounding down after dividing and multiplying by 2, respectively, for every time you shift, but it's often easier just to think of it as shifting all the ones and zeros left or right by the specified number of slots. All right. Oof, this is, oof. Man, this feels thick. Shifts, right? Shift operations are similar to rounding down. Multiplying by 2, respectively, for every time you shift. Wait, but it's easier to think of shifting all the ones and zeros. Okay. I'm not going to write that because I'm just going to do this one. Shifting. Oh my god. As bad as today is, yesterday was worse, so there's that. All the ones and zeros to the right or left by the specified number of slots. Kind of like multiplying by like tens, and then you just kind of put zeros in the end there. That's what I'm guessing. You can only do bitwise operations on an integer. Only on integers only. Okay. So what does it want us to do here? Shift the variable shift right to the right twice, and shift the variable shift left to the left twice. Try to guess what the printed output would be. Okay, 2. So we have this one here. 2, it would be 1 1 0 0 0 0. And this one would be 1 0 0 1, right? No. Okay, so we shifted to the right. So that one would be 1 1, so it'd be 4. No, 3. 1 1 is 3. 1 1 is 3. And then if we do the other one, shift to the left, we add like zeros after the fact, so it'd be 1 0 0, which is 4. I think so. It should print like 3 and 4. Oops. I made that error. Okay, well, I was correct, but I changed it into base 10 instead of just leaving it as binary, but it was right. It was 11 and 100, so I guess I see how that works. bit of this and that. Now we're doing ands together. Bitwise AND operator compares two numbers on a bit level and returns a number where the bits of that number are turned on if the corresponding bits of both numbers are turned on. Okay. We'll get through this. Will we understand it? Know where to use it? Perhaps not, but here we go. And operand. Ooh, somebody else joined our work group. No. They didn't. Nobody did. Why am I getting a notification then? I don't know. Oh well. Okay. Where were we? And operators. Bit of this and that. Compares numbers. Binary numbers. And returns a number where both numbers bits are turned on. So 1, not 0. So example. Okay, we're saying 0, 0, 1, 0, 1, 0, 1, 0, which is 2. Then B is 0, 0, 0, 0. Oh, we just put zeros as placeholders there. 0, 0, 0, 0, 1, 1, 1, 1, which is 15. And what's it going to return? It's going to return 0, 1, 0, 1, 0, 0, 0, 0, which is what? We've seen that before. Is that 10? Yes. This is A and B. Okay, I understand how it works. I don't have any idea why you would use that or when you would use it. But now we're going to learn how to use it. So remember, for every given bit in A and B, 0 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, and 1 and 1 is 1. So that one will equal 1, 1, 1, and 1, 0, 1, 0 equals 1, 0. Which equals 2. I got no clues as to why you would even do this. I got nothing here, but they're saying this is part of Python, so let's do it. Print out the result of calling bin on this.
Bits are really good for flags.
Flags?
Like single bits to say, yes, this has been done, no, it needs to be done.
Oh, so like doing a test. Like if this flag is 0,
Yeah.
then run it until it's 1, then now we break out the loop.
Yeah.
And then do the next thing. Woo, that'll be handy maybe for what we need to do with it. So we gotta check all those things. Okay, so for checks. Thank you. I got some idea of what to do with it. Okay, so we want to print. Do we need to compare first? well. How do we write it together? I don't know about this. I don't know about this. Print bin 0B1110 and 0B101. And what's it going to be? It's going to be 100, which was 4. Yes, 100 is 4, so it should print 4. Oh, it printed 100, which is 4. Okay, but bin doesn't print integers, it will only print the output of the number in binary, so that's where I took it a step too far. This for that. I guess I can, thankfully they gave it to me here so I can like copy paste it, but I have no idea where that is on my keyboard. Hey, where's this guy? Right?
It looks like the pipeline operator. Shift.
Ah, shift that one? Oh, I didn't know that was, I thought that was 2. Okay.
Well, it depends on
maybe
the
it shows
font,
up like 1
but-
here. Let's see. Let me see what it looks like. Yeah, that's it. Thank
Yep. It's usually called the pipeline operator.
you. All right.
Where throw whatever comes out of this into that.
All right. What am I doing here? This time. Okay, we know where to find that now. It returns a number where the bits of that number are turned on if either of the corresponding bits are turned on. For example, let's write down the word example. Compares binary numbers. On a bit level and returns a number where either of the corresponding numbers are. Write down the example, switch colors. So the same numbers as in the previous one, but we'll see, we get a different result. This is 1, 2, and this one is 2, 3, 4 zeros, and 1, 2, 3, 4 ones is 15. And that would get us this time 47. 0, 0, 1, 0, 1, 1, 1. Okay. Print out the results of using that on that. It's a binary string. Try to do it on your own without using the operand. Let's. But it says don't use, it says use this, then don't use it, and then use it. What? Wait, I don't know. I don't think so. No. Oh, we don't want integer, we want bin. There we go. Okay. So an hour left. I'm confident we'll get through this module. This XOR that. Exclusive OR operator. There's two numbers on a bit level and returns a number where the bits of that number are turned on if either of the corresponding bits of the numbers are 1, but not both. So it will be 1 if it's 0, 1 or 1, 0, like put together, but not 0, 0 or 1, 1. Okay. If either digit is 1, but not both. That's how it's different. Okay, and then let me write the example. It's the same as above. A is 0, 0, 1, 0, 1, 0, 1, 0, which is 42, and B is 0, 0, 1, 1, 1, 1, which is 15. And putting them together like that. This and is this symbol. This one is a bar, and this one is the caret. There we go. And the caret will give us 0, 0, 1, 0, 0, 1, 0. Right? Which is 37. Okay, good. And XORing a number with itself will always result in 0. Okay. Print. Printy. No, print. Print the bin of 0B 1 1 1 0 XOR 0B 101. And what are we gonna get? Oh, I didn't put 0, I put O. 0B 101. What are we gonna get? 0. Wait. We'll get 1 0 1 1. Yep. Next. Now I feel like I'm getting it. Which means that it's about to flip the script. Not. The next one is the not operator. -2, -3, -4, -43, -124. So I guess it does the negative of one number further. Flips all the bits in a single number. What this actually means to the computer is actually very complicated, so we're not going to get into it. Just know that mathematically this is equivalent to adding 1 to the number and then making it negative. Equivalent to adding 1 to the number and making it negative. Okay, for example, and what's the non-symbol that tells them? -2, -3, -4, -43, and -124. Next, a bit mask is just a variable that aids you with bitwise operations. Okay, bit mask. So much vocab, this one. Variable that aids you with bitwise operations. Bitwise operations. This feels a little tough, but let's see. I'm going to write down the example. Maybe that will help me a little bit as I get started. Number equals 0, B 1 1 0 0, and mask equals 0, B 0 1 0 0. Desired equals number and mask. Means it would check which ones are on. If desired is greater than 0, print bit was on. Okay, I think I get this. Okay. You don't like it? Too bad. It is what it is. Okay, what are we doing here? We're defining a function. I know how to do that. It doesn't look like it right now. Can't even get the... typing is always my difficulty. With one argument input. Oh my god. You should check to see if the fourth bit from the right is on. Mask equals 0B, and it wants to know if the fourth bit from the right is on. So 1 1 1 0 0 0. That's the fourth bit for the right. Right? Yes. If mask equals, if mask greater than 1, greater than 0, which means if it is 1. I don't think that's right. Oops. Kind of like that better. Full screen it is. We need to add something else. That's what the mask is. But we want results equals input and mask. And if results is greater than 0, return on. Else turn off. Woo! Look at that. I feel like I know what I'm doing. Let's see what happens. I'm gonna dash my hopes on the rocks for the next one. Maybe not. Turn it on. I think I can do that. You can also use masks to turn a bit in a number on using that. For example, let's say I want to make sure the rightmost bit of number A is turned on. I could do this. 0, just 6, mask 0B1, that's the rightmost. Desired A or mask. So what's that mean? It's the color I'm wearing today. Like a collection of lipstick at my desk. Using the bitwise OR operator, right? That's OR. Yes. We'll turn a corresponding bit on if it's off, and leave it on if it's already on. Okay? And the editor is a variable A. Use a bit mask on the value A in order to achieve a result where the third bit from the right of A is turned on. 2, 3. 0B, third bit from the right, 100. Give us third bit from the right. Then we say result equals A or mask. And then print bin result. Okay. Nice. All right. Next. Knew I could turn it on. Knew it. Flip out. I bet I could do this one too. Ha ha ha. Ha 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 ha. All right. In the editor is the 8-bit variable A. Use a bit mask and the value A in order to achieve a result where all of the bits in A are flipped, meaning the XOR. If I do like a tilde A, does that work? I don't think so. I don't know. No, it did not work. Oh, I didn't use I used the wrong operator. Invalid syntax. Mask A. Result. What's the mask going to be? You'll need a mask the same length as A, in which all of the bits are turned on. 0B. 1, 1, 1, 1, 1, 1, 1, 1. Yes! Okay, next. Finally, You can also use the left shift and right shift operators to slide masks into place. Ugh. I feel like this is something where it seems easy how they're teaching me, but in application and usage, it's gonna be like, makes no sense. Like, this isn't what I remember, right? I feel like I know bitwise operators, sure, and then to put them into application is something else entirely likely. All right. A equals 0B101. 10th bit mask. Mask equals 0B1. Nice. What is this? Hold on. DJ Shadow. This is a good one. This is hilarious. Mask equals 0B1. Desired A or mask, right? A XOR mask. Okay. So you're gonna want to turn the 10th bit from the right of the integer A. Instead of writing out the entire number, we slide a bit over using the double less than operator. Okay. Go that way 9 spaces. Okay. Use 9 because we'll need to slide the mask 9 places over from the first bit to reach the 10th bit. Okay, so 1 less than what you want. Flip bit takes input number n. Flip the nth bit with the 1's bit being the first bit and store it in result. So result equals number. We have to do a mask first, right? Mask equals, and we want 0B1. I want it slid over how many spots? N spots. Is that right? Takes the inputs number and n. Flip the nth bit. Yes. So, yep. And store the result. Oh, but it's not just n. It's n minus 1. Yes. Yes, it is. And result is number XOR mask. And then we're going to return bin result. Okay. Okay. Oh, that was the last one. Nice. I feel like I need to write this example down because I'm not going to remember that you can just slide a mask over into where it's supposed to be. So we're just going to call this sliding mask. Flip it. There we go. And we're going to... Wow, I still have a bit of time too. Once I finish writing this down, I'll take like a quick 5-minute break maybe, and then we'll move on a little further today. My kids keep saying it's like summer already, and I feel that. I feel like every day this week I felt like Friday. I don't know if it's just because I'm like not like all into it or what, but I understand what they mean now. Okay. I'm done writing that down. So we're going to go to... In this lesson, we'll explain what classes are, why they're important, and how to use them effectively in object-oriented programming, which apparently Python is. So I'm going to take just a 5-10 minute break, and then we'll be back to move on a little bit further. Enjoy the music.
Remember how I told you Henley snake? When the baby grows up to be an old man, dies, they bury his body in the ground. But his soul goes to heaven. Now look here.
Oh, I'm bundled. I got my like 2 jackets on, 2 pair of pants, about 3 socks, hat. I need a mask too. Alright, it's cold. Real cold.
some good frequencies. 170, 2.6, 2,245,
Yeah.
3,032, 400.
400?
Yeah.
I'm coming over.
Do that.
I'll be there in 2 seconds.
object-oriented programming language. Okay. You can think of an object as a single data structure that contains data as well as functions. The functions of an object are called its methods. Okay, more vocab. I'm switching color. I'm going to purple now. No, orange. That's the color I picked up, was orange. Object oriented programming. And Python is one of those. And what does it do? Manipulates. Programming constructs. Called, you guessed it, objects. Okay. An object is a single data structure that contains data as well as functions. Structure that contains data as well as functions. Functions of an object and its methods. Functions of an object. There we go. Methods. Okay. For example, anytime you call when error, Python is checking to see whether the string object you pass through has a length, and if it does, it returns the value associated with that attribute. When you call myDictItems, Python checks to see if myDict is items method, which all dictionaries have, and executes that method if it finds it. But what makes Eric a string and myDict a dictionary? The fact that they're instances of the string and dictionary classes respectively. Okay, class is just a way of organizing and producing objects with similar attributes and methods. Okay, so I gotta write that down. A class my headphones are getting stuck. Stop it. Is a way of organizing and producing objects with similar attributes and methods. Objects with similar attributes and methods. Okay. Check out the code in the page. Right, we've defined our own class fruit and created a lemon instance. There we go. Is that gonna work? Maybe not. I don't know. There we go. Let's try that. There we go. Okay. Sure. I'm back. Everything gets a smiley face today. I don't know why. Because it's sunny outside, I guess. Everything gets a colon, right parentheses. Alright. A lemon instance. Okay. When you're ready, click run to get started creating classes and objects now. Okay, first let's see what it does. Okay, so class fruit object, a class that makes various tasty foods. It's just a comment for everybody about what it does. So we're defining a function in it that takes self, name, color, flavor, and poisonous inputs. And then we say self name is name, self color is color, self flavor is flavor, and self poisonous is poisonous. Then we define a function, description self, that takes an input. Description takes an input of self. Friends, I am a %% and I taste %. And then the %s are self color, self name, self flavor.
Now greetings to the world. Vice of the one big gangzilla alongside Skrillex. Them for no. Ooh-wee.
Define as edible, self. If not self poisonous, print, yep, I'm edible. Else print, don't eat me, I'm super poisonous. Okay, so they did if not because the output is a true or a false. So we just say if it's not true. Okay. And then we say, here's a lemon, it is a fruit. Its name is lemon, its color is yellow, its flavor is sour, and it's not poisonous. And then we print out the lemon description, which is I am a lemon, I am a yellow lemon, and I taste sour. And then, yep, I'm edible, will print out as well. Okay, let's try it. This is another layer being added on top. Okay. I doubt we'll get through this whole thing. I said that the last one too, but I mean for real, like I've only got 30 minutes left. Okay, class syntax. We need to write this down too. Super important. Class syntax. Class. New class. This gives them power and abilities. Icon object by convention. User defined icon class name. Start with capital letter. Okay. Basic class consists only of the class keyword, name of the class, and the class from which the new class inherits in parentheses. Okay. Hold on, I gotta get down and write this out. And the class from which the new class inherits. What's that even mean? It's right here for sure. Get to inheritance soon. Okay. Alright. Class keyword, name of the class, and the class from which the new class inherits. Class. Create a class called animal in the editor. Class. Oops. Get in the editor. There we go. Class. What are we saying? Class what? What class? What are we doing here? Class animal pass keyword. Okay, pass doesn't do anything, but it's useful as a placeholder in areas of your clever Python expects an expression. So pass animal pass. I think that's right. And let me write down this thing about pass. This doesn't do anything. Great placeholder. Where Python expects an expression. Okay. Run. Oh, I forgot the colon at the end. Every time. No? Class, animal, pass. What the heck? I think I spelled it right. End of line failure. No, end of function. Unexpected end of function while parsing. Whatever that means. Let's try this. No, it's not happy with pass. Does it need a space after it? Does that even make sense? I don't know. Do I not have it in the right order? Use the pass keyword. Is it pass at the front since class is the keyword here? Pass, class. No. Nope, it says class here. It's got to be class. Why? What is this? Do I make it pass? Nope. What is going on here? Right? Animal. Spelled correctly. Spelled correctly. What? Give me the solution. This is ridiculous. Okay, pass goes on the next line. Oh my god. I should have stuck with that a little longer. I should have. And pass goes on the next line. So let's do example. Class. Animal. Object. And then pass. Great, thanks. Next. Oh no. I want to try not to hurry through these either, because then I won't learn what I need to learn. I'll have to back up again like we did yesterday. Like our class to do more than nothing, so we'll have to replace pass with something else, okay? Class definition off an odd-looking function. Is that a double underscore? In it. This function is required for classes and is used to initialize the objects it creates. So we need, this is how you initialize objects. What is it? Let me see. Yes, it's 2 underscores. Underscore, underscore, in it, underscore, underscore, parentheses. No colon at the end. Right? Let's go back to the initial. There is a colon at the end. Oh, they're so tricky. Got me on that one. Okay. It always takes at least one argument self that refers to the object being created. Okay. You can think of init as the function that boots up each object class creates. At least one argument. Self. This needs a little highlighting. Remove the past statement in the class definition. Go ahead and define. For your animal class, pass it the argument self.
Hello, Lindsay. We got half an hour to much longer. How's your machine? It's stupid. It's a stupid machine.
Pass statement into your class definition.
That's hard.
And define it. Function for animal class. Pass self.
For this moment, it's back. Alright.
Is this
let
right?
me jump into your laptop and see what.
Is that how it goes? I don't know. Let's see. I'm gonna copy that and we're gonna go back and look at one. Here we go.
Not at the moment.
Self is here.
I think we're okay. I think I'm on your second screen with the beat first on it. And the lobster roll. Alright, so this is the computer that's slow or in New York? Okay.
This is self.
Well, I see one thing that's a little bit wrong with that. Click on this one.
Okay, what are we gonna do now? Let's do two things in the other. Pass and a second parameter name. In the body, let the function know that the name is
All right. Microsoft Word is happy.
self.name equals name. Okay, next. Instantiating. Instantiating the first object. I like that. Ah, maybe that's what it is. Okay. Next. Okay, now what are we doing? Instantiating your first object. Okay, we're gonna create an object. I guess that's what instantiating
All right.
is.
I guess the
You
next
access
thing
attributes
to
from
try
objects using
is show me where it's
documentation.
from.
Here's how it works. Class square. Self size
Yeah.
is 4. So self is used to add the attributes onto it, and you define what those attributes are, right? This is how I'm understanding this right now.
Yeah.
My shape equals square. Print my shape dot size.
Let's see how we can do right
Okay, first we name square with an attribute size. Outside the class definition, create a new instance of square in my shape and access
No,
that
that's
attribute.
not bad.
My shape.
Since you're on Wi-Fi, that's not bad.
Okay. Outside the animal class
I know you
definition.
don't have to with that. So this is not bad for Wi-Fi. Amazing.
Create a variable named zebra and set it equal to animal Jeffrey. Oh, this didn't end up going outside. It was outside. Damn it. There we go. Print zebra dot name. Maybe.
That's not bad at all. We're not losing.
So self is self. Name is
Yeah,
Jeffrey.
some line either to your building or to your
Self dot
neighborhood
name equals name.
is having a lot of trouble. And it's not the first time your office got had a short loss.
Okay.
I've seen it happen pretty consistently about once a week. Has Comcast come out and changed the line to the actual building from the pole? That you know of? Well, that's the first step.
More on init and self. Now that you're starting to understand how classes and objects work, it's worth delving a bit more into init and self. It can be confusing. Okay, great. More confusing stuff. 10 minutes to go.
All right. That's one hobby project you guys can take on. Get on Comcast's ass to change it to run a new line from the cell to the
Instance object would be
If
short for
that
initialize.
doesn't solve the intermittent cutouts, then it's happening somewhere where the whole neighborhood.
Hence initializing objects. I wrote the right thing. Hooray. First argument
Which usually
This
they're
gets-
on top of.
is used to
but
refer to
you
the
never-
instance object, and by convention, that
So,
object is called
At the very
self.
least, first thing, demand a brand new line from the building, from
Self
the building
is
to the
the.
pole.
Okay, hold on.
It's getting a little bit of interference, but it isn't too
Instance
bad.
object.
Otherwise, well, right here, right here. For a little bit, Yeah, so when everything's fine, you're
If
getting
you add additional
mid-
arguments, for instance,
right around
name,
50s and
age of your
60s.
animal,
This is
setting each
me.
of those equal to self
This
name,
is your
self age,
computer
and the
trying
body
to
of in it will make it
get
so that when you
replies
create an
directly.
instance or an object of your animal class,
50s and 60s, 50s
need
and
to give each
60s,
instance a
boom,
name and an age, and those will be associated with
500.
particular instance or grade.
That's delay, and then
Check out
you
the
got two
example.
packets
See
that
how
were
init
lost.
brings up each object to expect a name
They
and
just
an
didn't
age, then
they
uses
just
self
didn't
name
make
and
the
self
round trip.
age to assign the
to us.
names and ages to each object. Add a third
So
attribute is
something
hungry
happened
to
here.
init and
Somebody
return and click on to
touched
see the
something
results.
somewhere, either outside or in the wire. It really is. It really is. When if you're still using the original cable wire that was installed in 1982 when that TV premiered, yeah, then you probably need a brand new wire.
Zebra, animal, Jeffrey, true, false. Okay. Note that self is only used in the init. Function definition. We don't need to pass it to our instance objects. Okay.
I've had them do it right here.
Name, age,
I
say
had two of them.
true.
All
false.
right. Talk to you soon. Bye bye.
Hungry? Is hungry? Student in class. Okay, what do we say? True or false? Is that what we... What is it? Oh, is hungry. Okay. My god, that was so obvious. Cerulean. There we go, that should do it. Did it. Next. Scope. Alright. New definition. So many notes this session. Really short session, but lots of notes. Lots of stuff covered in this one. Class scope. The scope of a variable is the context in which it's visible to the program. Is context in which it's visible to the program. Okay. All variables are accessible to all parts of the program at all times. With classes, you can have variables that are everywhere, global variables, or member variables, or instance variables. I'm writing all of those down. Global. Global variable is available everywhere. Member variable is where available how members of a certain class. So members of a certain class. And then instance variables. Available to particular instance. Okay. Might seem obvious. It seems obvious to me now because I'm looking at it, but later on when it comes up, like in 2-3 days, I'm gonna be like, what was that? Gotta have notes. Gotta have notes. That's the last of my third cup of coffee today. Ugh, I'm having caffeine as if it's a Monday. Oh no. Class animal object is live equals true. Then, so all of them in the class will be listed as is alive, or is alive is true, and then each one gets its own name and age. Zebra, giraffe, panda, Chad, okay, 217. Front zebra name, zebra age, zebra is alive. Why can't we just... I see. Okay. Run. Now, why does that one go at the end? Because I said print it at the end. If I print it at the front of it too, that's fine. Okay, next. I get it. Next. Methodical approach. When a class has its own functions, those functions are called methods. You've already seen one such method in it. But you can also define your own methods. Add a method description. Oh my god, I don't think I'm ready for this. Description takes name and age. Yeah. Okay. Add a method description to your animal class. So, define description. Should print out name and age of the animal it's called on. Okay. Then create an instance. Of animal, hippo. How do we do that again? Animal equals hippo. Harry, his name's Harry, and his age is 12. And call its description method. Print description animal. Line 12. Hippo's not defined. Hippo equals maybe it's like that. No. 13. Description is not defined. it, does that make it print animal hippo? Ah, and animal would have to be like what, hippo, right? Or am I supposed to put self there? Is that right? There's only 2 arguments given. Okay, hold on, let's copy this and then we'll look at the standard one at the beginning again. Because it's gonna like undo this when we go back, but let's go back a few and look. And then I'm gonna have to call it self.name is name, age is age. Zebra is animal. Okay, so I gotta put hippo is animal and then put the information in. Ooh, hold on. This was okay with it? It's mad at me, but it's saying it's okay? There we go. Remember to pass self as an argument to description, otherwise printing self name, self age won't work, since Python won't know which self that is. Okay, we got that one. All right, we got to call it for today. That's it. See you all tomorrow.